In this video, we're going to talk about determining empirical formulas. And first, I'm just going to go through a breakdown of the overall process. You want to first assume you have 100 grams of the compound, and you're going to convert to grams of each element using the percent composition. This is because percent composition is just another way of saying for every 100 grams of compound, this many grams is a particular element. Next, you're going to convert the grams of the elements to moles of each element. You do this by dividing each by the atomic mass. You will then write a starting formula, a pseudo formula, using those moles amounts as the subscripts. It's going to look kind of ugly, but you'll fix that in a minute. You're going to take the smallest of those mole subscripts and you're going to divide all of the subscripts by that smallest value. This gets you to your first whole number, because when you divide a number by itself, that gets you to 1. Then you're going to multiply all of the subscripts by whole numbers until you get to the smallest whole number ratios you can. So if you happen to get to all whole numbers, but you notice you could divide everything by 2 or divide everything by 3 and still be in whole numbers, you should do that to get to the empirical formula. And this step is where it can be very useful to have memorized the decimal amounts of certain kinds of fractions, because you can multiply by the denominator of that fraction amount to get to a whole number. For example, if you see you have one of your subscripts ending in a 0.5, you can multiply things by 2, because if you multiply a half by 2, you get to 1. Similarly, if you see 0.33 or 0.66, try multiplying by 3, because you're obviously in thirds. Over here, I've put in sixths and eighths, because those are fairly common to see, but they're not ones that people are very familiar with. So now that we've seen the general process, let's go ahead and take a look at this in action.
A common mineral in Earth's crust has the following percent composition: 34.55% magnesium, 19.96% silicon, 45.49% oxygen. What is its empirical formula? First step, we're going to assume we have 100 grams of this, because then we can directly convert the percent composition to grams of stuff. So in 100 grams of our compound, we will have 34.55 grams of magnesium, 19.96 grams of silicon, and 45.49 grams of oxygen. Now, in each case, we're just going to divide by the atomic mass to get to moles of each of these things. So we're going to divide the magnesium grams by 24.305 grams per mole, which gets us to 1.422 moles of magnesium. And we'll do the same thing with the silicon and the oxygen. So this one's 28.086 grams per mole, meaning that we have 0.7107 moles of silicon. And then the oxygen, that 15.9994 comes back, meaning that we have 2.843 moles of oxygen. Remember, keep an eye on your significant figures. Now that we have the moles amounts, we're going to use these as the subscripts in our pseudo formula. So magnesium 1.422, silicon 0.7107, oxygen 2.843. The 0.7107 is the smallest subscript, so we're going to divide all of those subscripts by that particular value. If we do that, we get magnesium 2, silicon 1, oxygen 4. We're in all whole numbers now, so that's a good thing. We need to now check to make sure that this is the lowest value for each of these atoms possible. Now, since we have only one silicon, we can't go any lower than that. Therefore, this is our lowest combination of numbers, and this is the official empirical formula. We'll write it out correctly. Mg2SiO4. This happens to be peridot, a common gemstone. It's very common to use empirical formulas for minerals and ceramics because they don't have a molecular structure like things that are made out of carbon and oxygen tend to. So this is the most easy way for us to represent their overall formula. I'll see you guys on Monday.